Now we'll discuss about conservation of energy. In this universe, total energy is conserved. So in this universe, energy, total energy is conserved. Okay, how it happened? We can neither create nor destroy energy. So we cannot create or destroy energy, but we can change one form of energy to another form. But we can change one form of energy to another form of energy. Okay, so the total energy remains constant because we only change the form of energy, but we cannot create or destroy energy. So the total energy is remain the same. This is called the conservation principle. So this is the conservation principle. So we can state the conservation principle as the energy can neither be created neither be created nor nor can be nor can be destroyed nor can be destroyed. So what can we do? We can do but can do but can not do but can only be converted one form to another one form to another, and this is known as principle of conservation of energy. So this is called conservation principle. This is called conservation principle. Now we'll see the conservation principle applied in our mechanical energy, and we'll saw some example of this principle. First of all, we take an example of freely falling body. Freely falling body. So suppose it is a building height of h, and here is a body which is the mass of m, which is at which is at 8 h height, and we put that ball down, and we make this ball to freely falling from that point h. So we take 3 points. We'll take 3 points. One is point A, another one is point B, and another one is point C. And this height B to C, we take this as x. So automatically it will be h minus x. Okay, remember this thing. Now first of all, we have to find out the total mechanical energy at point A. So total mechanical energy is equals to the kinetic energy plus potential energy. You have to remember this formula. So at point A, total mechanical energy is equals to, here as our body is at rest position. So there is only, so the so what should I say, as this is at rest position, so at this point our V is equals to 0. So in that case our total kinetic energy is 0. But what is our mechanical energy? We know this is the concept of gravitational energy, and that concept, when we use that concept, the that concept gives us the formula of potential energy is mgh. Here h means the height from the ground. So at that a point, the height from the ground h is h. So height from the ground is h. So for a, our potential energy will be mgh. So our total energy is mgh. Now coming at point b. At point b, our total mechanical energy is equals to, we have to calculate. Now at point b, it has some velocity and it travels, and it has the distance of x. It has the distance of x from the ground. So first of all, calculate the total mechanical energy for so first of all, we calculate the kinetic energy. We know the formula of kinetic energy, half of mv square, and we know the formula of potential energy is mg. Suppose we replace this h as capital H, capital H. Now we have to find out the v square. We know v square equals to v naught square plus 2s. Here, for this concept, when our body is point A, the v naught is 0. When is the body is point A, our v naught is 0. So our v naught is 0, and our acceleration is occurred due to gravitational acceleration. So we replace this a to g, and as this is the distance, as what is s is the distance, and the distance it traveled from point a to point b is h minus x. The distance it traveled from point a to point b is h minus x. So we will, instead of v square, we will use half of m h minus x plus. Here now I have to find out the value of capital H. So what is the value of capital H? As it is at point B, the height from the ground to point B is x. The height from the ground to point B is x. So so our height will be, our capital H will be x. If we, okay, I missed something. Okay, I missed 2g. Okay, so here it will be 2g of h minus x. Okay, now if I calculate whole thing, 2 will be gone. Then I will get mg h minus mgx plus of mgx, which is equals to mgh. So our total mechanical at point A is mgh, and total mechanical energy of point B is also mgh. Now I have to find out the total mechanical energy at point C. So if I have to find out the total mechanical energy of point C, here at point C, at point C, our distance from this ground to ground is 0. So our distance h equals to 0. And what is the value of v? When it comes from point A to point B, it will have some velocity v. So we have to find out the velocity v. So now again go to this part. We know when our body is point A, the v naught is 0. Okay, so I put this as 0. I put g instead of a. So now we have to calculate the s. S, it travels from point A to C. It travels the distance h. So our for that case, so at point C, so our distance is s. Instead of s, we will use h. So now we have to put down this whole thing. We can find out the total potential energy, kinetic energy is half of m v square plus total potential energy. We know our h is 0. As our h is 0, our total potential energy, as if h is 0, then our total potential energy will be 0. So this whole term will be 0. So at point A, our kinetic energy is 0, and at point C, our potential energy is 0. Now I replace this v square with this part, then I will get half of m 2gh. So if I cutting down 2, I will get mgh. So I found that at every point, like at point A, point B, point C, at these 3 points, our total energy is conserved, because there is no change of total energy. The total energy is conserved. Different case, our energy is convert to potential energy to kinetic energy to potential energy, and their value is changed, but total mechanical energy is unchanged. Now take another example. Now we'll see another example, which is body falling along a smooth inclined plane. So now suppose this is the inclined path, create an angle theta with the horizontal axis. Okay, and here we have a body which is the velocity, which is not velocity, which is the mass of m, and this is our point A. And suppose after some time t second, it this body fall this point to this point, really falling from this A point to B point. At A point, its velocity is 0, and at B point, it has some velocity v. And when it comes from A to B with freely falling, then it has mg sin theta. This mg sin theta, due to this mg sin theta force, it falls from point A to point B. And we discussed this thing mg sin theta, why it is mg sin theta. This component we discussed in our previous work video. So we have to remember this thing. And this g sin theta represent the acceleration part. This for this total force, this g sin theta represent our acceleration part. Okay. And when it comes to point A to point B, it travels x distance. It travels x distance. We also remember, we have to remember this part also. Okay. Now at point A, at point A, our total mechanical energy is kinetic energy plus potential energy. When V is 0 at point A, so our kinetic energy is 0, and potential energy, suppose the height from the ground to point A is h, so we will represent potential energy is mg h. So our total mechanical energy is mg h. Now at point B, we know it travels the distance x, and we know it is coming due to the force mg sin theta. Mg sin theta is represent our acceleration part. So total mechanical energy is kinetic energy plus potential energy. And for kinetic energy, we know the kinetic energy is half of mv square. A total potential energy mg is supposed to represent h as capital H. Okay, so you have to find out this v and this h. For v, we know the formula of v square equals to v naught square plus 2as. We know v naught is 0 because at point A our initial velocity is 0, and we represent this a as 2g sin theta. So we represent our a as g sin of theta. I discussed that earlier. And what is as the displacement, or the distance it travels from point A to point B, and we represent this as x. So we find out 2gx sin theta, 2gx sin theta. So if I write this thing, I will get the 2 will be gone, and I will get mgx sin theta, mgx sin theta. So I find out our kinetic part. Now I have to find out the potential energy part. Now we have to find out the h, value of h. So what is the value of h? The value of h determine the distance from ground to the point it has. Now at our body is point B, so suppose we represent this as D, so the height will be from ground, as it is C to D. We have to find out this height CD. We have to find out this height CD. So what is CD? Here we know CD equals to AC minus AD, AC minus AD, and AC equals to H. Here our AC equals to H, and what is AD? We have to find out now AD. As this is theta, that will also be theta, and we know the value of this x. So what will be the value of this AD? It will be x sin theta. What is the value of the AD? X sin theta, according to the Pythagoras law. If we use Pythagoras law, we will find AD equals to x sin theta. So we represent this AD equals to x sin theta. Okay, so we find out h minus x sin theta. So instead of h, we will represent mg h minus x sin theta. So we write this whole formula. Now if I write the whole equation, it will be mgh minus mgx sin theta. So this and this will be cutting down, and what will I get? The total energy, mechanical energy, will be mgh. So I find out at point A the total mechanical energy is mgh, and at point B the total mechanical energy is mgh. So the principle of conservation is successfully applied. It conserves the energy. Okay, so this is the whole concept of conservation of energy, and I give two examples to understand better what is the conservation of mechanical energy. Hope you understand the whole concept of this video. This conservation energy is most used and needed term in our for our mathematical problem. So understand this thing in understand this concept very briefly, or and understand this concept to solve the mathematical problems. I hope you like this video. Do subscribe to our channel and turn on your notification bell. Thank you.